Hi, this is the second video for multi-step equations. We're going to look at clearing fractions in this lesson. So what's new for this part is we still need to distribute, but the new part is the clearing method. So if we have fractions, we don't have to do fractions the way that we've traditionally done them. We can use the clearing method to get rid of the denominators, changing fractions into regular whole number coefficients. And then we're going to definitely collect our like terms and isolate the variable as we've been doing in the previous lessons. In this first example, we see that we have denominators of 4, 3, and 6, and then we have x, and x is just kind of over 1, but we don't have to write it like that, but we are going to treat that as a term and find our LCD. So our lowest common denominator of 4, 3, and 6 is 12. So that means that we're going to multiply every single term, even the x term, by 12. So I'm going to put 12 over 1 multiplied by the first term, 3x over 4, minus 12 over 1 times 2x over 3 equals 12 over 1 times 5/6 plus 12 over 1 times x. Or you could just write it as 12 times x. And that's what I'm going to do. I'm going to make that change because I'm not multiplying to a fraction. Therefore, I don't need to put 12 over 1. Now we're going to do the clearing step. Each of the times that we multiply, we can cross-reduce, therefore eliminating our denominator. So we're going to divide by 4 here, and 12 divided by 4 is 3. And I'm going to do all the clearing at once, or you can do one term by term, solving each term multiplication as well. It's up to you. So I'm going to divide by 3, divide by 3. On the other side of the equal sign, I'm going to divide by 6 and divide by 6. So I've done the cross-reducing all at once, and now I'm ready to do the multiplication step. 3 times 3x is 9x, minus 4 times 2x is 8x, equals 2 times 5 is 10, plus 12 times x is 12x. We can now see on the left-hand side, I have 9x minus 8x. That's wonderful. I can combine like terms. 9 minus 8 is 1, so I'm going to be left with 1x, or just x, is equal to 10 plus 12x. I'm going to move the 12x over to the left so that my two variable terms are combined. So I'm going to subtract 12x on both sides, canceling on the right. And remember, this is like 1x minus 12x, so this is going to be negative 11x is equal to 10. Now I can isolate the variable through division. I'm going to divide by negative 11 on both sides. And I have completed the solving now. There's no reducing required. X is equal to negative 10 over 11. If you remember this question from class on page 217, what we did here before we knew the clearing method is we subtracted half z from the right-hand side and moved it over and subtracted it from 1z on the left-hand side. And then we multiplied by the reciprocal in order to solve for z. Now that we know the clearing method, we can do things differently if we want to. We can see that I have a fraction, right? We have half z. And it's only one fraction, which means that its denominator is the lowest common denominator. And that means we can multiply each term by 2, therefore clearing the fraction. So let's do that. 2 times z is equal to 2 over 1 times half z plus 2 times 4. Every term has to be multiplied by 2 in order for this to work. So we're going to go ahead and do the clearing. We can now eliminate because we're going to divide them by 2, and we can do the multiplication step. 2 times z is 2z is equal to 1 times 1z is just 1z or z plus 2 times 4 is 8. Now we can collect our like terms. Again, we're going to use subtraction, but we're now, because we've doubled everything, we're now going to subtract a full z, not a half z. So we subtract that away, canceling, subtract z, 2z minus 1z is equal to 1z, or z, and that is equal to 8. So we come to the same result. Without the fractions, we use the clearing method to, in effect, double everything, but we still get the result of z is equal to 8. Now you can go ahead and try each of the student example questions on page 222. If you feel stuck, you can watch the video for the solutions. All right, we see we have fractions here. We want to clear them, so our first step is to find the lowest common denominator. Between 3 and 2, that's 6. So we're going to be multiplying each and every term by 6. 6 over 1 times x over 3 plus 6 over 1 times a half equals 6 times negative 2x. All right, now I can do the clearing. I'm going to divide by 3 for the first term, and I'm going to divide by 2 for the second term. That means my denominators I can clear away, and I can do the multiplication now. 2 times x is 2x, plus 3 times 1 is 3, equals 6 times negative 2x is negative 12x. In this example, we really don't have a choice. We need to move the x, the 2x, over to the right. We're going to collect our like terms. So I'm going to subtract 2x, subtract 2x. That will cancel over on the left-hand side, leaving me with 3 is equal to, and again, be careful with your signs, negative 12x minus 2x. You may want to do same, change, opposite, and then you can see that the result is a negative 14x. At this point, we can isolate the variable. We're going to divide by negative 14 on both sides, canceling there on the right, and so x is equal to 3 over negative 14, or you can pop the sign up in the numerator. You can write it with x over on the left as your final answer, whatever you prefer there. For b, we have 3 terms, all have a denominator. We're going to find our lowest common denominator. LCD of 4, 3, and 2 is 12, so each term will be multiplied by 12. If you don't want to put 12 over 1, absolutely you don't have to, but a lot of times I find that it's helpful, especially at the start. So we're going to multiply by 12 in the first term, plus 12 over 1 times 1/3 x. For our second term is equal to 12 over 1 multiplied by negative half. I'm going to clear the fractions now. Divide by 4, cross reduce, divide by 3, divide by 2. My fractions are now cleared. I can do multiplication. 3 times negative 3x is negative 9x, plus 4 times 1x is 4x, equals 6 times negative 1 is negative 6. I have the variable terms both on the left, so I can now combine them. Negative 9x plus 4x is negative 5x, is equal to negative 6. And now I can isolate through division. Divide by negative 5, canceling, and divide by negative 5. X is going to be equal to a positive number because I have a negative 6 over a negative 5. So we will have a positive 6/5 as the result here. For this last question, you have two options. You can multiply each by the LCD, which is 6, or you can cross multiply, which is a bit faster. Again, we have a proportion here. Proportions go quicker. You can multiply 3 times 5 minus x and 2 times 2x plus 3. And then you can collect like terms and isolate. So I'm going to show it that way. So 2 multiplied to 2x plus 3 is equal to 3 multiplied to 5 minus x. Now we're going to distribute. We've already cleared the fractions because we have a nice proportion. So we're able to do things a bit more quickly. 2 times 2x is 4x. 2 times 3 is 6. Equals 3 times 5 is 15. And 3 times negative x is negative 3x. Now we're going to collect like terms. Variable terms on one side, constants on the other side. You can do in any order you want. I'm going to add 3x to both sides. That's how I'm going to begin. 4x plus 3x is 7x. Plus 6 is equal to 15. Now I'm going to move my 6 over to the right through subtraction, canceling, and I'll put my answer over here. 7x is equal to 15 minus 6, which is 9. And my final step is the division. I'll divide by 7 on both sides of the equation. X is equal to 9 over 7. It's no problem to do clearing fractions the traditional way, even in a proportion question like this. We determined the LCD was 6. You could multiply everything by 6 over 1 and everything here by 6 over 1. And when you go to do the clearing, you're going to divide by 3 and divide by 2. And you will be able to then distribute as we did when we did the cross multiplication. So they're really both perfect. It's a matter of choosing what you're more comfortable with when you have fractions. I hope you find clearing fractions enjoyable, and best wishes on the practice exercises. I can never say that word. On page 223, 224, 225.